Hello and welcome to another episode of Slam TV. We have a special episode for you folks at home today. We're going to talk about amortized loans and mortgages. Luckily for you folks, we have a special guest with us here today. He's known as the mortgages master. He's the finance phenom. He creates amortization tables at the dinner table. He's Jay Cho.
Thank you.
Jay, how's it going, buddy?
Hey, how are you doing?
Good. Hey, did you buy that Ferrari yet for your midlife crisis?
Oh, that Ferrari. Actually, funny thing is, the other day I went to the dealer.
The
just
Ferrari
down the
dealer?
street, exactly.
Right.
And I was in line, and then this lady was like, "If you're gonna spend that much money on your car,
Uh-huh.
why don't you buy a house?" I'm like, "Oh, a house? Maybe that's better than a car."
Don't people go broke buying houses?
Yeah, remember the housing bubble?
I know. I mean, I think a lot of people are scared to buy houses because so many people bought houses they couldn't afford, and then
Right.
the house foreclosed, and it's like,
All sorts
wow.
of problems. Exactly.
So how do I know if I'm spending too much money on my mortgage?
Right. You don't want to spend all your income on the housing payment.
Okay.
They recommend that no more than 28% of your gross monthly income.
Gross. Ew.
No. That means before tax. It doesn't mean gross.
Before taxes. Got
Exactly.
it.
Exactly. So, what is your gross monthly income?
It's about $6,000.
Right. So, 28% of $6,000.
Uh-huh.
So, 0.28 times $6,000, $1,680.
Oh.
So, make sure your payment is no more than that for the house payment.
Okay.
Right.
So if I have a 30-year mortgage and I have to make a monthly payment, how
Right.
many total payments is that going to be?
Right. So, you're making monthly payment, right? So
Uh-huh.
that means 12 times a year.
Uh-huh.
And if you want to do 30 years,
Uh-huh.
that means 30 times 12. So that's 360 payments.
360 payments.
Right.
Cool.
So
So I think I can figure out how much I need to pay per month if I just take $300,000.
So you want to buy a house that's $300,000?
Yeah.
Wow. Okay.
Living large,
okay.
baby.
Living large.
Living
Living large.
Let's say I
Okay.
buy a $300,000 house.
Okay.
Okay. And you said that there were 360 payments
Right.
for the whole 30 years, right?
Exactly.
So if I take $300,000, divide by 360,
Okay.
I get $833.33.
Right.
Excuse me, no one is going to lend you $300,000 for free. Aren't you forgetting about interest?
What?
Who is that
What
guy?
is that voice? Is that Leo?
Excuse me, Roger, could you move over a bit?
Luckily for you folks at home, we have a special guest for you today. He's known as the boss of the bankers. He gets freaky with the finance. He ain't never going broke. He's Jens Christen.
Yeah, my friends call me Jens Christen, but you can call me Banker Jens.
Wow. Banker Jens, welcome.
Thank you.
Could you tell our viewers a little bit about what an amortized loan or a mortgage is?
Well, mortgage is a special type of loan. It's a loan when a borrower and a lender can take advantage of the power of compound interest.
Oh, cool. Is there a formula for this?
Oh, yes, there is.
Wow.
Oh my God.
That is so complicated.
I think
Well,
my head just exploded.
Maybe we should break it down and look at it from two perspectives, from the borrower's perspective and the lender's perspective.
Okay, that's a good idea. Luckily for us, we have a borrower and a lender. Jay, could you lead us through the borrower's point of view?
Sure, let's look at, oh, wow, okay. Oh, you know what? It's not as bad as you think it is. I think we've seen this before. Do you remember this from last time?
Part of it looks kind of familiar to me.
Right, we talked about, there's another case where we take advantage of the power of compound interest. Remember?
Oh, give me a hint, give me a hint, give me a hint. Give me a
It
hint.
rhymes with gratuity.
Annuity.
Exactly. That's exactly right. That's exactly right.
Why don't we lead our students through the annuity formula
Okay,
again?
okay. So we're looking at the right-hand side of the equation.
Okay, and then if we think of that as an annuity, I see we have all these different letters. What does
Okay.
the N stand for again?
N's the number of times it get compounded, or how many payments you make in 1 year. So it'll be 12 because you're making a monthly payment.
Oh, okay. And what does the T stand for again?
T's time in years. We're taking 30-year loan, so it'll be 30.
Cool. And R?
R is the interest rate. Like we'll say it's 5%. And of course, when you do calculation, you're going to convert that into decimal. So it'd be 0.05.
Oh, okay.
Mm-hmm.
So it looks to me like there's still two things in our formula that haven't been filled out yet. What's this FV and this PYMT again?
Right, the PYMT is the payment. That's how much monthly payment you're gonna make.
That's like my mortgage payment?
Right. And the future value is, I don't know.
Well, maybe I can help here.
Oh, Jens, can you fill us in on what this future value and payment should be?
Yes, as a lender, obviously, I'm trying to take advantage of you. But, well, seriously, I'm trying to take advantage of compound interest.
Oh.
And if I have $300,000 that I would like to invest, compounded for 5% for 30 years, then I can make a decision and think, well, do I just want to invest it or will I lend it to Jay?
Lend it to Jay. Yes. Okay. So, if I wanted to buy if I want to take out a $300,000 loan, and I want to take advantage of the power of compounding, from the banker's point of view, how much money will they expect at the end of 30 years?
Well, that's when we look at the left side of the formula, and this is again a formula we know. It's the compound interest formula you calculated before.
Right. Can you lead us through this compound interest formula? What does the P stand for?
Well, P is the principal. In this case, it's the $300,000 that I would invest or lend to Jay.
What about the R?
Well, the R is the interest rates we agreed on, the 5%.
Oh, yeah, right. We already talked about that. And the N was?
And the N is the number of payments for each month, which means it's going to be the 12 payments.
Oh, number of payments per year.
Per year, yes.
So, got it. So the N is 12.
Correct.
Cool. And in our case, what's T?
And T is still the 30 years.
Ah, cool. Awesome. So at the end of this calculation, when we plug everything into the computer, what do we get?
Well, if we put it all into this machine, we get oh, very nice. We get $1,340,323.29.
Wow. More than $1 million. I have to pay that much money? I don't have that much money.
That's the power of compounding.
That's so much money. For $300,000 house, I have to pay more than $1 million?
No, of course not. Because we're both taking advantage of the power of compounding.
I get it. So for your point of view, that's what you're expecting at the end.
Exactly.
And from your point of view,
I'm trying to match that by investing a certain amount of money every month.
Let's revisit that annuities formula again.
So I think now we know what the future value is.
Okay.
Jens, thanks for calculating for us.
Sure.
1,300,000, the long number, about $1.3 million.
About 1.3 million, right?
So now we can plug in all the numbers in. So we know on the left-hand side, I have about $1.3 million. On the right-hand side, I have everything else except the payment. Now we can solve for the payment.
Okay. So let's say we solve for the payment using algebra.
Right. So since you want to solve for the payment by itself, you want to divide both sides by the number on the right.
Okay. And what do we get if we plug all of that stuff into our formula?
All right. Oh, cool. $1,610.46. Okay.
Oh,
that's manageable.
It's manageable.
It's not that bad. It's not that bad.
I see. Cool. So, Jens, why don't you sort of tie this whole discussion of our formula together again? Can you just break down everything we just talked about?
And Banker Jens, thank you very much.
I'm sorry.
Wow.
So if we look back at our formula, we can see on the right-hand side, what Jay already calculated, that we have his perspective as a borrower. And on the left-hand side, you have the perspective as a lender of the future value that I'm trying to make.
Got it. So we set his sort of annuity side, which is on the right, equal to your compound interest side, which is on the left. And then it all just works out, huh?
Correct.
Awesome. So how much will Jay end up paying in total?
Well, we calculated, or you two calculated, that Jay will pay $1,610.46 each month. Now he pays it for 12 months, for 30 years. So calculating everything together, we get $579,765.60.
Wow. That is still a lot of money.
It's like almost like 2 houses, but it's way better than $1.3 million.
That's true.
Right.
That's true.
Right.
So, Jay, how much interest did we end up paying?
Well, according to Jens,
Banker Jens.
oh,
Thank you,
I
Dan.
paid $579,765.60. But I borrowed $300,000. So basically, I look at the difference. So I subtract those one number from the other one. I get $279,765.60. That's how much I paid in interest.
Wow.
That's a lot of money.
Dude, you could buy a house and a Ferrari with that money.
Wow.
But remember, guys, you don't want to overspend, so you don't want to spend more than 28% of your gross monthly salary.
Oh, okay.
So let me ask you, Jaden, how much is your gross monthly salary?
$6,000.
Really? You didn't go to college? Okay, be that as it may. So we can actually figure it out. We have 28% of the $6,000. And putting into our calculator, we get $1,680. Well, that's your payments of $1,610.46 are still less.
Yes.
So you're fine, Jay.
Means I can borrow your money. Yay! And I ain't going broke.
I'ma take it to the top. Yeah, never gone broke, never gone broke. Never gone broke, never gone broke. Never gone broke, never gone broke.